Today on the Garage Engineer Shop, we're going to talk about why I switched over from the old traditional circuit tester to a 12-volt power probe. Let's check it out. So in this video, I'm going to split it up into two parts. The first part is just going to be a quick overview of the 5 things of why I like the power probe and why I'm using it now. The second half, I'm going to go more in detail of those 5 things, plus kind of give you an example of why this power probe is safer than using the old style continuity tester. That way, if you're here just to want to find out about the power probe, you can watch the first half of the video. Or if you're more interested in going more in depth of the power probe and how it can be used and why it's safer for the newer vehicles, then you can watch the second half. And if you're interested in purchasing the power probe for yourself, there will be a link to the Amazon shop in the video description below. Check it out. First off, I want to say that although I do love my power probe and even the old continuity tester, I still think everyone should learn how to use a multimeter because this really teaches you about the circuitry and how electricity and electronics work. I still use, this is a cheap Harbor Freight multimeter. Now it's not going to be as precise as some of like the Flukes, but this will get a lot of the job done when you're working with automotive. You don't need to be that super precise. Plus it's cheap, so if it breaks, you throw it away, or if you lose it, it's alright. I keep multiple copies of these, some in the shop, some in my vehicles, just so I can do quick diagnosis testing if I'm on the road. Now, if you do want to step up, a little bit more expensive than the Harbor Freight, but does very well, I've got this Astro AI. The reason I like this one is because it has an amp clamp on here, so you might want to get some testing for amperages if you're doing parasitic draw and different things like this. And if you really want to get technical, I love my Fluke meter. This really gets down to the microamps, like it's 4 decimal places down if you're doing amperage, and then it has all the other features of checking voltage, and it's just more reliable, more accurate. But again, in the automotive sense, the Harbor Freight multimeter is fine. I mean, for what you're doing, you're just testing voltages and general amperages. You're not really trying to get down to the microamp level of figuring out a circuit. So besides all that, learn how to use a multimeter and what all that means is the first thing, because you'll get a better idea of why circuits work the way they do. Alright, let's get into it. So the first thing you do to set up your power probe, you just connect the positive clamp to the positive on the battery and the negative on the negative clamp. So the first feature I like about this is that it can sense positive and negative without having to move anything around. You can just touch a wire and tell if it's grounded or if it has a positive power. So this comes with an LED light. And this is going to tell you red if it's a positive, getting positive power, or green if it's negative. So I'm just going to touch it. And you see how it's turned red because I'm touching the positive side of the battery or the circuit. So there's circuitry inside here that knows the direction. So again, touch the negative and it turns green. So that's telling me this is the ground side of the circuit. So that's the first feature of why I like this. So for feature number 2 of why I like the power probe over the old circuit tester is that the circuit testers used to come with an incandescent light. And that had about a 270 milliamp draw on the circuit. And so with now modern technology and you get more sensitive electronic equipment, that's not acceptable. And we'll go into the latter half of the video. I'll explain why. But this isn't as safe on current vehicles. Now, some of these circuit testers come with LEDs, and I've switched this bulb out to an LED bulb, and it still produces about 66 milliamps of power, but that's still too much for me when you're testing sensitive equipment. Whereas if you go to the power probe, this only draws 4 milliamps, and we'll again show all this later in the video. But that's why it is computer safe for your vehicle. So for the third feature of the power probe, this has a little button right here. You push up for positive and you get a red line. Now what's this doing? This is doing is sending 12 volts to the tip of that. So whatever you touch, it will add 12 volts to it. If you push down on the button, you get a green light, and that's showing that you can test for ground in the circuit. Now what makes this great is that you can test in the vehicle or out of the vehicle circuits to see if they're working or not. You're applying a 12-volt voltage to something to see, like a light bulb, if it lights up, to tell if it's good or not. And if you want to do and if you're on the negative side of the circuit, you can hit the ground and it will draw power from the battery through the circuit and draw this down directly to the ground. That's if you have a short down the line in the circuit in the ground and you want to bypass it and you just want to make sure that circuit works. So we'll talk about more about it, but you got to be careful applying 12-volt voltage to your circuit because if you do it the wrong way, it could fry something. Feature number 4 I like about this is that it's a continuity tester. So what you can do is you take this extra lead that it comes, this is basically connected to the negative, and this is your negative lead, attach that to your component, and then all you have to do is touch the tip of the probe to the other side and it'll tell you if there's continuity going through it. And for the 5th feature, this is more something they said. It's okay. It's not really the big thing of the power probe. But basically, since you've got a negative on one end, and then you've got the this negative adapter next to the probe, and you've got a 4-meter line, the company says you can use this as basically a circuit lead. So if you needed to test something and it was far away, well, you just unplug the positive from the battery, and basically you're just using this as a long wire with 2 alligator clips on the end of it. So that might come in handy. That's not a main feature of the power probe, but that's just something in addition to it. And we can show that later, how the continuity goes from here to here. So it's just one big long wire that you have a 4-meter of, that if you ever needed to do some testing with a multimeter or something like that, you've got that. So those are the 5 major features of the power probe of what they say the power probe can do. So now let's go further into depth and I can explain why the power probe is better for newer cars and also show you some of the examples of how to use the power probe in testing. So let's begin by talking about the real-life usage of the power probe. But first, let's do a little bit of technical information just to show why the power probe is better for current day vehicles rather than the old circuit tester. So whenever you're testing amperage, you've got to use your multimeter in series of the circuit. So we've got a circuit built up here. You got the positive. What it's going to do is go to the multimeter through the amp setting. We got it set to milliamps. Then it's going to come out of the negative, go into the tip of the continuity tester, go through our LED light, and then back to the negative of the battery. So you're breaking up the circuit rather than just touching the tester right to the positive. We're breaking up the circuit so that the meter is in line with the entire circuit. Whereas when you test voltage, you can just stick the probes right up on the battery that's in parallel and you can test the voltage. But for amperage, you've got to break the circuit up. So by doing this, if you look at the fluke meter here, it's set to milliamps. When we hit the positive probe onto the power of the battery, the light comes on here, but also you see it's 65 milliamps. Now if this was an incandescent bulb, that would show over 250, 270 milliamps. That's going to be significant in a minute, but let's mark that down and we'll have that written. We'll call it CT equals 66 milliamps. That's going to be important in our test in the future, and we'll have that written down. So now I'm going to replace our power probe in this circuit, and then we'll give that a test. So now we've got the same setup, except now we've got the power probe set up into the circuit rather than the continuity tester. Now I have this set up with the positive on the positive post and the negative on a negative post. You can do this test without this, but I want to see real life examples, and I did want to show you a difference too. So what we're going to do now is we're going to test the amperage of the, basically it's the LED light is what's drawing everything out of here, out of the circuit. So if you push the probe onto the positive, you're getting 5 milliamps. So that's going to be important again in our test circuit. So we're going to write this down as power probe equals 5 milliamps. Now I did notice if you take this off, which in this test it doesn't really matter if you got the power on there and you do the test, it does jump up to 8 milliamps. So that's very insignificant when you're talking about the grand scheme of things, but I thought that was kind of interesting. And also you can test it too to prove that this is also the negative lead. It's just shorter when we're doing our continuity testing. So that's negative on there, and then you touch it, again you get the 8 milliamps. So that's basically, this lead is the same thing as hooking up this alligator clip. So that was just something I was just showing you. But the main purpose of this test was to show that LED only draws 5 milliamps. Alright, so here is a scenario. This is like a circuit in our modern vehicles. You've got your battery. It's sending 130 milliamps to this component, because that's what this component is requesting. And then it sends that to the ECU. And the max, let's say the max typical amperage for switches or anything in the ECU is 300 milliamps. So that's why that's the 300 max at what it can take before you fry anything, any component in your ECU. So normally sending power, the battery's supplying 130 milliamps. The battery's supplying it this way. So let's say we're doing some testing and we connect our continuity tester from this line and we jump it to here to test the see if power is coming there. So what we're going to do is we're going to hook up our continuity tester, and it's going to touch right here. Now if this is the old style continuity tester, that is giving, what did we say, 273. So that's giving 273 milliamps with that incandescent bulb, if this is the old style tester. So it's sending 230 milliamps this way, but this component is also sending 130 milliamps too, also from the battery. The battery's supplying all that amperage. So when by the time you get here, you're at, let's see if my math is correct, 303 milliamps is coming down past this point. And this is just test examples, but let's say this is over, this is the max of the ECU component, so you just blew it just by using the old incandescent bulb. Now if with the newer ones, now by switching out the LED bulbs with the in the continuity tester, we went to 66 milliamps. That would lower this, and it would be in somewhat of a safe range. So that take you down to 196 milliamps. So you are within the safe range of the ECU, but that's still adding a lot of load when you're not really sure. But by adding the power probe, you're only adding only 5 milliamps more to whatever it's sending down. So you're only affecting this ECU by 135. So that way the power probe is safe doing the testing, and you're not having to worry about, am I going to blow my ECU or some type of electronic component because I'm adding too much amperage to the circuit. So that's the whole reason why I wanted to show what the different amperages were for the different tests, and why I like the power probe over the circuit tester. Alright, so let's start testing with the power probe. I set up a simple circuit here. We've got a battery with a positive on this end. It's going to a switch. The switch is going to our light bulb, and the light bulb is back to the ground. So this is going to just show different components of like what you would find in your vehicle. Alright, now with our power probe set up, we got our power probe here. And let's do some testing. So let's say you're in the vehicle and you're at the switch and you want to know which side is the positive side of the switch, which side is the negative. So right now it's off, the switch is off, so there's no connection, there's no power flowing through it. So if you touch the power probe to one of the sides, you get a red, and that's telling you that this side is the power side and this is a negative. And the reason why you can tell that is because the circuit is broken, so you're broken too. So if you had a connector, you'd have to pull the connector apart to determine the positive and negative side of the switch, so you know which way the wire is flowing. Now if this was powered on, then it would show power all the way through the circuit there. See, there's power. So you need to break the circuit up somehow to determine if there's power or ground going to it. So for continuity testing, again, we connect the probe up to the positive and the negative. And now we have our simple switch that we want to test continuity. So I'll just use the accessory negative and attach that to one of the sides. And then the switch, we don't know if it's on or off. So we touch the probe to the other side of the component, and you see we do not have a light lighting up. Now, if we switch the switch on to complete the circuit, it lights up green because the power is going to the negative, and it's showing that it is a continuous circuit. So that's showing that this component is good because it's got flow through it. Alright, for the next feature, we're going to test components inside of the vehicle. We're going to continue to have our setup here, but let's pretend that there is a break in this light bulb circuit, and we wanted to apply power to it just to test to make sure that the bulb works. Now what we would do is, before we apply any voltage, I always want to test with the probe just to make sure that's showing that this is the ground side of the circuit and you're not getting any voltage. You're not on the positive side of it, and that's because this is disconnected from the power. Now what we need to do is you push the button to the positive side and it lights up red. And by touching it to the negative side, we're sending 12 volts through the circuit and showing that the light bulb works. So that's showing it in the vehicle that it's testing. Now what if we wanted to test the component, same component, but outside the vehicle? Let's pretend this component is outside of the vehicle and we would just want to test it to see if it worked. First we'd add our negative clip to one side of the component, then we'd push positive to apply 12 volts of power to the tip, and then you touch it. There you go. So that's showing that the component works. This is different than continuity test, because the continuity test is we're just testing to see if there's continuity through the light bulb. This we're actually testing, applying power to it to make sure that it works properly. You see, this is just testing continuity. When you get the green, that means continuity is being tested and the bulb is still good. But then with the red, you're applying power. Just like that. Alright, so I decided to come outside the shop to do some real-world testing to kind of show you what this can also do, give you some other ideas of the use of the power probe. What we got here is setting up our 4x8 trailer, and I want to test the lights. Now, the trailers don't have their own batteries, or at least this one doesn't. Some of the car haulers do. But what we did was we set up the power probe, what we got here, to our little battery, or this is our motorcycle battery. We grounded out the battery to the trailer so it has a good ground, and then we're going to test the plug. So first, before I apply any power, I want to test to make sure we've got good grounds here. So I'm not pushing any of the buttons, I'm just testing the connectors to the power probe, and if you touch it, you get a green light, and that's showing a good ground. Right there. You got to get a good ground on it. There you go. And then this one is ground, and there you go. That's strong. So these are all your lights. I think that's your brake, that's your lights, and that's your marker lights. So with that being said, now we're going to use our apply positive power. So we got the red light, and we're going to apply it to the middle, and that should turn on the backlight brake lights. So that's a good way to test trailer lights if you don't have a vehicle with you. And you can also check the light bulbs to see if they work. So going back to using the power probe leads as maybe a long extension cord, using just the blacks, the accessory black and the main black wire. There's many possibilities you could use it, but let's say you wanted to, you're testing the circuit and you needed the ground and you didn't have access to the ground in the back of the trailer and you wanted to test the ground. You can connect this to the battery and then connect this to your multimeter and then do your testing with the multimeter that way if you needed to find exact voltages or something like that. I mean, there's a lot of ways you could use it. That's just one. But I did want to show the continuity. I'm going to put the continuity on the beeping noise on the multimeter. You always check before continuity. You hear that beeping, so that means it's good. So basically, clipping one to one side of the multimeter and one lead to the other, and so it's just one long wire. There's continuity running through this. So that's what they're talking about, having a 4-meter lead for doing diagnostic testing. I did want to mention, if you get the exact same power probe that I mentioned, I just curious and was going over the instructions, which is basically 2 sheets of a piece of paper. It's translated, so it took me a while to actually read through to understand what they're saying. I did want to make a note. If you look on the last 2 paragraphs of what this can do, one of them's called, let's see, jumper lead operations. There's actually 2 of them that are titled the same. I'm going by the second one. I called it number 2, the jumper lead operations, and then short circuit following and locating. I do not think that applies to this model, because what it's asking you to do is to put the 2 clips on the battery, the positive negative, and then basically apply power to the power side. And it's saying if that power side is active, then it will trip the circuit and a buzzing sound would be made, and it will cause the machine to shut down. This does have overload protection up to 7 amps, but I actually did a few testing of it to see if I could get it to trip, and it never did trip. So I'm not sure these instructions were made for that model, so just be wary of that. If you do get these and you actually try and follow the directions, that might not work. If you can get it to work, feel free to let me know in the comments below that you got that to work and how you got it to work. But I tried different ways to do it, and it didn't. There's no buzzing, and I was worried about overloading the circuit. It didn't break it. It also didn't work either, how they said. So just kind of keep that in mind with these instructions. Well, thank you for coming along on this adventure. I enjoyed showing why I like this power probe and the things that it could do. If you're interested in getting one for yourself, the model number and a link to the item is listed in the video description below. I hope you click that link and take a look at it. And if you do decide to purchase it, there's no extra cost to you, but it does help the channel so we can continue to make videos like this. And if you'd like to see more videos like the one that you just saw, you can check here and here. And remember the ABCs of making. Always be creative. Till next time.